We are on number 5, so let's take a look. A deck of cards is composed of 20 cards with 5 cards from each of the colors red, green, blue, and purple. Within each group of color, the cards are numbered 1 through 5. A single card is drawn at random. We're going to define events B, the card is blue, R, the card is red, and N, the number on the card is at most 3. Okay, now before we actually start answering the questions, let's just list our sample space. Alright, so we have red, green, blue, and purple cards, and they're numbered 1 through 5. So I'm going to just say R1 for red 1, red 2, red 3, red 4, red 5. And same thing for green. Green 1, green 2, 3, 4, and 5. And then blue, blue 1, 2, 3, 4, and 5. And purple, we'll call that P. P1, 2, 3, 4, and 5. Alright, so that's our sample space. Well, now let's look at part A. We want to list the outcomes that comprise event B, R, and N. Alright, so let's look at event B first. So B is the cards that are blue. Alright, well, we can look up in our sample space. That's B1, B2, all the way to B5. Alright, well, let's see, we also want event R, which is red cards. So if we look in our sample space, that's R1 through R5. And then lastly, N is the number on the card is at most 3. So we're talking 1s, 2s, and 3s. 4 and 5 would be more than 3. So we're looking at all cards that have a 1, 2, or a 3. So if we look R1, R2, R3, G1, G2, G3, B1, B2, B3, and P1, P2, P3. Alright, so part B, we want to list the outcomes that comprise the events below, or all of these events. Well, let's take them a piece at a time. Get that out of the superscript mode there. Alright, so let's first do B intersect R. Get my little intersect symbol. Okay, so we're looking for what B and R have in common. Remember, our upside down U is what they have in common. So if we look at these two, they really have nothing in common. So this is the empty set, which we can symbolize with just empty set of brackets. Alright, well, let's look at B union R. Now remember, that means we want to put the two events together. So let's just list everything in both of the events. Oops. Yep. Keep missing my key there. Alright, and let's go to B union N. Again, we're going to put both events together, and we don't want to repeat anything, though, that we've already got. So I'll list the B stuff first. And then if we look at N, we've got the first 3 elements, and then the next 3 elements. I don't need to put the B elements again, but I can go ahead and put the P elements. And there's B union N. Now let's get R union N. So same idea. Let's we just want to put them together. So I'll list the R elements first. right, and then if we look at N, we've already got the first three elements in there, so we'll go to our G, B's, and P's. Alright, and now we want B complement. Alright, so B complement. Remember, that's everything in our sample space that's not in B. So B contains all of our blue cards. We're going to list everything that's not a blue card. So, oops, all of our red cards are not blue. All of our green cards. And of course all of our purple cards. Alright, then we need B union R complement. Now we've got B union R right here. Let's notice it comprises all of the blue cards and all of the red cards. So the complement is going to be the cards that are not blue or red, so the cards that are green and purple. So B union R complement will be our green cards and our purple cards. Alright, so we've got A and B. Alright, so now, assuming that events are equally likely, we want to find all the probabilities for the events that we listed in part B here. Okay, so let's just do them off to the side here. So if we look at the probability of B intersect R, well, since there's nothing in the set, there's no way for us to get any outcomes, so that probability is 0. Alright, but let's take a look at B union R. If we look at, we've got 10 elements in this set, and there are 20 overall elements or outcomes in the entire sample. So the probability of B union R is 10 out of 20, or 1/2, or we can list it as 0.5 if we want to. Alright, let's look at B union N. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 elements out of the 20. So the probability of B union N is 14 out of 20, which reduces to 7/10, or you can list it as 0.7. Alright, R union N, same idea. Alright, so if we look at that, we have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 again. So 14 out of 20 again. And then if we look at B complement, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 elements. So probability of B complement is going to be 15 out of 20, which reduces to 3/4, or 0.75 if you make it a decimal. And if we look at B union R complement, there are 10 elements in there. So the probability of B union R complement is 10 out of 20, or 1/2. Okay, so that's C. Now let's look at D. Determine if B and N are mutually exclusive. Now remember that 2 events are mutually exclusive if they have nothing in common. So let's look up here and let's notice that B and N have the elements B1, B2, and B3 in common. So they are not mutually exclusive. So our answer to D is no. B and N are not mutually exclusive. They have 3 outcomes in common. And of course, it only takes one for them to be not mutually exclusive. Okay, so now if we were to ask if B and R were mutually exclusive, the answer would be yes, because notice that that intersection was the empty set. All right, so let's go to 6, and hopefully I'll have time for this. So 6, the breakdown of students enrolled in a college by class and academic major is shown in this two-way classification table. We want to find all of the probabilities listed below, assuming that a student is chosen at random. So let's look at the probability that a student is a junior. All right, so let's notice we have an entire column of juniors. To help us out, I am going to add to this table, and I'm going to add a column to the right. So I'm going to insert a column to the right, and I'm going to insert a row on the bottom. Alright, so what I've done is made a column of totals and a row of totals. So just briefly, if I add up all across the STEM majors here, that will be this total of 96. If I add up all these liberal arts majors along this row, that'll be the 386, and so on. If I add all the freshmen going straight down, that'll be the 451, and the sophomores going straight down, and the juniors, and so forth. And we'll see how these totals will help us. And then if we add up all of this column, we get 2,000, or we can add up all of this row, and it will also add to 2,000. That's one way to check and make sure you've added your totals correctly. All right, so the student is a junior. We want to find the probability that the student is a junior. So let's find the total number of juniors, which if we look down this column, it's 577. And we're going to put 577 divided by 2,000. And of course, if you want to put that into your calculator, you can change it into a decimal. All right, so let's look at B. The student is a health major. Well, again, let's find all of the health majors. So here is our row for health. If we go all the way across, there are 501 health majors. So there's 501 out of the total 2,000. The student is a senior business major. All right, so our business majors are right here in this row, but we want the business majors that are seniors. Well, here's the senior column, and the business majors, there's 274 senior business majors. So 274 out of 2,000. All right, now, question D is a little more complicated because we are dealing with a conditional probability. We want to find the probability that someone is a freshman given they're a health major. And we have this formula for conditional probabilities. So we need the probability that they are a freshman and a health major. So, there we go. And a health major over the probability that they are a health major, the second one in our notation. So let's take a look at, and we can actually boil this down to the number who are a freshman and a health major. So freshman health majors, let's notice, are 110. Now if we want to, we can do 110 over 2,000. And then on the bottom of the fraction, the probability of health majors, well, our health majors, there are 501 out of 2,000. And what happens when we deal with this fraction is the 2,000s on both the denominators will cancel, and we get 110 out of 501. And I am running out of time for question E, so we'll get that in the next video.